And welcome everybody to the Daily Space Weather. This is SNN. Least busted name in news. Did you hear about Dr. Fauci? He's being promoted to Emperor of the Universe. I'm really excited about it. We'll all be safe from COVID thanks to Dr. Fauci. We're starting out today's Daily Space Weather looking at the sun in 335 angstroms to see sunspot 2780 having just risen over the northeastern limb. Another active region rising in the southeast as sunspot 2778 and 79 set in the southwest. So we've got some great views here on HelioViewer, starting out with sunspot 2778 and 2779 as their umbrae just move out of view in the past 24 hours. Great view of the magnetic looping associated with those sunspot regions. And next we'll look at the active region in the southeast. It's looking bigger than the one that's just risen in the northeast. So we would expect that to be a sunspot as well. We do see umbrae associated. Oh, it looks like some ejecta there as well. And right here we see a little bit of ejecta. I didn't see anything on the stereo A imagery, so no apparent coronal mass ejections from that yet. Great view of that little filamentary behavior. Here's sunspot 2780, and it is in this area, I believe, is where that new sunspot is located. We'll see if it stays having umbra for over 12 hours, in which case it will get named. And lastly, here's a full disk view. As there's so much going on, we didn't want to zoom in on every region, but a great view of a bunch of activity there in 304 angstroms, ionized helium emission spectra. By the way, we are streaming live to Twitch right now. It's twitch.tv/smAsho. The typical streaming platform that we use here at the Smash News Network, because it is so good. We love it. So now today's Smash Lights segment is a separate video, so make sure you watch that. It'll air after the Daily Space Weather at 6 a.m. So make sure you tune into that, the Smash Lights, and we typically include that. Don't forget to follow us on Twitter. Remember that all things matter. Don't forget to link to our Teespring store and so on. All things matter. Today's featured clothing is the All Things Matter shirt in red. Since all things matter, especially red waves, it's in Republican red for a reason. And you can link out to all of that at smashomash.com. Just click on the SmAsho store and you'll see that. There's also affiliate links there. We've dipped our tippy toe into the Amazon space. Thanks for everybody who's followed us on Twitter. And here's a little brief cosmology segment. Now, we spend lots of time talking about cosmic rays, as it is not common knowledge that cosmic rays affect Earth's climate, as cloud cover makes the planet cooler in the daytime and warmer at nighttime. We also spend a lot of time talking about Deneb, which is the most intrinsically luminous object visible from Earth. It's located somewhere between 3 and 37,000 light years distance out in the constellation Cygnus, and it's involved with Cygnus X3, a massive X-ray binary, and it's quite interesting. By the way, it's just come out of its quiescent state here. You can see the past couple days here, it's been around 0.04, so it's more around its baseline now, and we're interested to see if that comes up into its active state. And so we keep an eye on it regularly. If you want to read all about Cygnus X3, Deneb, head to smashomash.com/forum. Go to the Cosmology Forum. There's a whole thread just about that particular star. And let's talk about heliophysics, as heliophysics is pretty important. And mankind really does not understand the shape of the heliosphere. There's all kinds of conjecture. It's shaped like a sphere. It's shaped like a banana. It's shaped like a sheep's bladder. It may be employed to prevent earthquakes. Who knows? But there's a lot of conjecture about the heliosphere and its shape, and it's kind of important, as the sun is orbiting the galactic core at sort of a slow speed, but with respect to other closer stars, the real motion between the sun's motion and those other stars is different than the way its orbit behaves around the galactic core. And this causes us to have various different theories about the shape of the heliosphere. And here is a map of the hydrogen density. So you can see we've got dense regions of hydrogen over here, dense regions of hydrogen over here, and then like almost none back here over toward the constellation Leo. Do you think this might be an indication that the heliosphere is crescent-shaped? It could be an indication. So in any case, we did get a comment the other day about the hydrogen wall outside the, quote, solar system. So this is sort of important when it comes to cosmology. And ultimately, we really don't know how the shape of the heliosphere is oriented or anything like that. The only real data points that we have are the New Horizons, but more importantly, Voyager 1 and Voyager 2, which have attempted to leave the heliosphere in the bow shock region. And here's a nice little animation of sort of a zoom out from the sun, just a little animation of what the heliosphere might look like. Some people think it's comet-shaped. Some people think it's spherical. And I think the poloidal fields of the sun have some sort of an effect on this. I don't want to get into it too deep, as this is the Daily Space Weather, and this cosmology segment is not a standalone video. So, but in any case, when you leave the solar system, there is actually a higher hydrogen density out there. It's kind of similar to the Earth's heliosphere, perhaps. Although, citing Eugene Bagashev's statement, the Earth does not have an Earth wind like the solar wind. So keep in mind, stars and planets are very different, and their heliospheres are likely to be shaped differently as well. So perhaps check that out. All about the density of hydrogen outside the solar system. And there's that great map of that area. And yeah, leave us a comment if you have ideas about how the bow shock is shaped, or how the heliosphere in general is shaped. It's very important when it comes to heliophysics and cosmology. Heliophysics and cosmology, yes. And that's today's cosmology segment. By the way, we are streaming live to Twitch once again, twitch.tv/smAsho. Thanks to all of our viewers over there, people leaving comments. Please don't forget to press like and subscribe if you enjoy the content on YouTube. Please share with your friends, foes, science noobs, and science pros. We're also on BitChute. There are exclusive videos over there, such as our most recent BitChute exclusive, Banks of the River Styx BitChute exclusive. Let's talk Turkey. Alt tech is the answer. Please branch out into alt tech. Use things like Minds.com as an alternative to Facebook and so on, as there needs to be competition in the marketplace. Otherwise, you may be told lies. Lots and lots of lies by big tech. And it's, let's just say it's been causing me to get a little bit enraged. All right, enough of that. And let's get back to data of the space variety. Next, looking at the real-time solar wind, we see a recently shifty phi angle and a recent little spike here in the solar wind density. We are expecting a coronal hole wind stream by tomorrow or Wednesday. Current solar wind density only 3.7 protons per cubic centimeter. Phi angle currently in a state of flux, and solar wind speed around 350 kilometers a second, having ramped down to sort of background levels once again. The KP index, a measurement of global geomagnetism, is at 1, having come off its lows of 0, and we see a weak magnetosphere as a result of that low density, low speed solar wind. So here's a 4-hour animation of the magnetosphere. It's courtesy University of Michigan. And again, you see that very low pressure associated with that low speed. I think I got a tab out of order. I apologize. Oh, we're missing a tab, folks. There we go. Here are the ground geospace magnetic perturbations. We do see some magnetism here, and we show this daily since we're living through a polar excursion. We've got 2 North Poles, one over Canada, one over Siberia, and the South Pole is somewhere south of Australia as opposed to on the Antarctic continent. And we see pulses out of the South Pacific as we did last year around this time, as well as to the southwest of Australia in the southern Indian Ocean. And we are very interested in what is going on with the geomagnetism on the planet, how it's generated. Leave us a comment if you have a theory about the generation of Earth's geospace, geomagnetic field, whatever you want to call it. We did see some C-class flares kick off here, and the probability of flares has gone up a little bit as we see 2 active regions rising in the east. So while we see some setting sunspots, we also see some rising active regions, including at least one umbra. Sunspot 2780, most likely to be named today. I would bet that it will be. Here's where stuff is in the solar system. There's where things will be in 1 week. And bear with me one moment, folks. I just need to check the life of the stream and so on. To Acacia 12826. I don't know how I hurt my knee. That's why it's so weird. But it's coming back, and everything is looking pretty good now. Anyway, there's where we expect things to be in 1 week, as Mercury and Venus race around to the backside of the sun once again. I like to use in-the-sky.org for my star charts. And let's draw in the ecliptic. By the way, if you're up before dawn, I always face my sky chart to the south, since that's where the ecliptic's located, and also my sofa faces the south. If you're up before dawn, you may see Jupiter and Mars and the moon all at once. Venus should be rising soon as well. Let's take a look at the magnetism here of the heliospheric current sheet. So we're looking at the top view ecliptic plane field plot. Earth is solidly in the South Pole oriented current sheet shown here in red. We're not expecting any changes of that soon, although we got to keep an eye on those active regions. And when I say eye on, well, the pun is intentional. Here's a line of sight field plot showing the B field in blue. And the B field is really a product of the South Poloidal field and the North Poloidal field's interaction. To the extent that they overlap is the extent that the B field is there. And the reason that we look at this is because it gives us insight into the relative strength of the North and South solar polar fields. Anyway, nothing too exciting happening there, nothing too out of the ordinary. You can see the B field being pulled down here towards sunspot 2778 and 2779. Here's the potential field force line plot of the corona itself, looking at just the solar atmosphere, otherwise known as the corona. It's got its own magnetic field force lines. And keep in mind, this shows you closed potential field force lines in pink, open potential field force lines in black, and coronal hole field force lines in purple. Let's talk about Earth's Van Allen belts. We cover the data daily, and Earth's electron belts are a bit important into things like geospace, also satellite drag and GPS communications. And this great diagram here from NASA does show you a visualization of the inner belt, the outer belt. And we do get a third layer here too during geomagnetic storms and so on. It's also showing you the location of GPS satellites versus low Earth orbits such as the International Space Station. Here's a 1-year chart of the relativistic electron flux, and we're in fairly normal levels here. We've come off of the warning levels. There's a 7-day chart, as we did see an electron storm there for a few days, coming back into more normal levels here. Don't be surprised to see this go back into warning levels a bit today. Keep in mind, that means noon, and that means midnight local time for the GOES 16 satellite. Here's a visualization of the total electron content. Like sands through the hourglass of time, so are electrons through the geospace. We do see some anomalies here. You can see some nighttime charge-ups here over the Middle East. Persian Gulf. Seeing some unexpected GPS errors at nighttime there. Otherwise, not too out of the ordinary. next, looking at just one slice of the atmosphere, as that was the entire air column up to the thermosphere. Here's just the ionosphere layer, which, by the way, is where the GOES 16 endeavors to make its measurements. This one's courtesy of Bureau of Meteorology, Government of Australia. And it's looking fairly normal here. Nothing too exciting to comment on. There's the latest image, 10 o'clock Universal Time. Let's talk about this typhoon. It's bad news. Millions of people evacuated and at least 10 dead as a result of a monsoon season that it's a little bit out of the ordinary. And indeed, crop losses are a thing, just not in the northeast portion of North America. Anyway, a super typhoon blew into the eastern Philippines with disastrous force Sunday. Let's hope the cleanup operation is going well there. Bad times for Philippines. Let's look at the earthquakes of the past 24. It looks like we haven't seen anything over a 6 magnitude. Let's make sure. Now we're just going to scroll up the list. Here we see a deep quake in western South America. One of the most common spots for deep earthquakes on planet Earth. And there's another one, that's a 4.0. Here's a deep quake at Papua New Guinea. So again, no big quakes here. We're just going to scroll up the list. Leave a comment if we've missed anything, or if you'd like to add anything to our coverage as we consider the SMASH team part of the collaborative effort that is these videos. Looks like the largest of the past 24 was just a 5.0 at Vanuatu, and that is at depth. So a bit of a lull in earthquakes happening there. And we've got some new drone technology improving the ability to forecast volcanic eruptions. Yes, flying drones around to take samples of the gas produced in volcanic eruptions. This article in the Earth section at phys.org, if you want to have a read about that, feel free. Good news about volcano prediction, as its CO2 output, water vapor output, sulfur output, and so on are all associated with how much activity a volcano is going to have. And so it's a good idea to fly sensors above the volcanoes to take samples of the chemical composition of the volcanic ash plume.
Its way forward to allow access
or volcanic gas plume, as it were.
Accessible.
So this is a great idea. Cheers. We like to see. Shout out to the University College of London. Let's look at volcanoes of the past 24 hours. It looks like we've got at least one new one on the list here that I've never even heard of before. But Karimsky on the Kamchatka Peninsula is producing its 17,000-foot ash plume. Abiko is producing a 14,000-foot ash plume as it explodes. Sakurajima, unknown volcanic ash cloud there. Please don't attempt to pole vault the caldera. Suwanosejima, 5,000-foot ash plume there. Semaru, 14,000-foot ash plume there. Tokono, 7,000-foot ash plume there. And Korovin in the Aleutian Islands. While activity is low, we see increased sulfur dioxide emissions, which may be a sign of seismic unrest. Something to keep an eye on. The Korovin Volcano in the Aleutian Islands. Popocatépetl has dissipated its ashes down there near Mexico City. Pacaya back to exploding. An effusive eruption produced about a 1,200-foot, we'll say 1,500-foot ash plume. Telica back on the list, exploding down in Nicaragua, producing a 2,000-foot ash plume. Sangay, 19,000-foot ash plume as it explodes. Revenador exploding, 15,000-foot ash plume. Sabancaya exploding, 24,000-foot ash plume. Please do not build a campsite on the lower slopes of Sabancaya. It could make for a bad camp. Next, looking at nullschool.net to see the jet streams of the eastern world. There you go. Some extreme meridional jet stream flow in the south there. And here are the jet streams of the western world. Cold air being injected into New England here now. And let's move on to windy.com. We'll advance the GFS forecast for pressure. We're looking at pressure cells right now. And before I get into that, look at the chat. By the way, if you're viewing our live premiere, thanks for everybody tuning in to the live premiere events. We enjoy watching the videos with our viewers. And keep in mind that I'm not only smAsho, but I'm also a client. So we're just going to advance this into tomorrow. And here's where we expect things to be at 12 noon on Election Day. Make sure you get out there and vote. And make sure you vote for somebody who's not a complete COVIDiot. I would greatly appreciate it, as I'm getting sick of having my civil liberties eroded by people who know less about infectious diseases than Bernie Sanders does about economics. Next, looking at the lightningmaps.org. It's what I like to use when I hear thunder. I try to convince my foes that I'm Thor by forecasting thunder, and we don't see any terrestrial thunder in the U.S. right now. Let's look at the NASA GOES 16 lightning mapper. And we see a long band of lightning here approaching Bermuda. Shout out to Bermuda! Leave us a comment if you're viewing from the island nation, one of the spots where I'd like a vacation. Here is the U.S. Doppler Radar Map, and we see significant snow over Pennsylvania and most of the state of New York. Some of it is pretty heavy, as we're getting that cold air blasting down from Canada. Here's what's going on in the cloud layer. And we're going to show you the water vapor map, zoom in of Pennsylvania here. We'll show you around Binghamton is where we've centered the map. Binghamton, New York. And there you can see that cold air making it all the way down to North Carolina, it looks like. Making for some cold days in the Northeast, Mid-Atlantic, and New England. And you see some crazy pressure gradients. If you're flying a plane across any of these areas, expect some turbulence. And let's just take a look at this area here out in the ocean as well, as there's an interesting front zone there. And if you're on a boat in these areas, expect some high seas. And for you new viewers, remember, dry massive air such as this dry air here is generally more massive than this moist air here, as the molecular mass of nitrogen, N2 molecular nitrogen, is more massive than water vapor. By the way, thanks for tuning in, Smash Team. Don't forget to visit our links. Thanks for flying American Smashways. Please keep your head and arms inside the Smash plane at all times. We've got bonus features. We're going to show you the 94 angstroms 48-hour SDO video. We're going to show you the intensity gram, the latest refresh of it. And we're going to show you the colorized magnetogram. If I could stop hitting the wrong keys, I would show you it more quickly. And we've put them in a different order for no real reason. So in any case, I see ombre. There, we've got two ombre associated with Sunspot 2780, increasing the likelihood that it's going to get named. Let's check it out in the colorized magnetogram. And those are two opposite polarity ombre, making this a beta class sunspot. More interesting than the alpha class sunspots in that there are two polarities, as we've got a north polarity umbra and a south polarity umbra, making it yet another Cycle 25 sunspot. Welcome to Solar Cycle 25. Welcome to the Neo Renaissance. Thanks for tuning in. And what have I done? I've ruined everything. Here are the ombre. This one is North Pole. This one is South Pole, making it a beta class sunspot. There are the colorized magnetograms, showing you visualization of what I've just stated. And here's the 94 angstroms view, one of my personal favorites. It's one of the many ionized states of iron. This takes 10 images per minute instead of only 2, something that only the 94 and 131 angstroms views do. And we zoomed out a little bit so we can see the timestamps. Again, thanks for tuning in. Allow me to vanish and thank you. Especially patrons, the real source of funding. Please consider becoming a patron. Patreon.com/smAshomash. And may that solar wind be at your back, and that covidiously absent from your government. By the way, those C flares came out of Sunspot 2778 and or 2779. You could actually see it in that final image.